This is section 2.1, and we're now into part 3 of 2.1, where we're going to be writing function rules and evaluating functions. So this first video here, we're going to be evaluating functions, and let's talk about what a function rule is. It says here, a function rule is an equation that represents an output value in terms of an input value. Something you might want to maybe jot down in your notes. A function rule is simply a fancy word for an equation. That's it. Okay. You can write a function rule in what we call function notation. All right. So function notation. Most of the time when you see an equation, it looks like so. It looks like y equals x plus 1. Function notation simply replaces the y with what we call f of x. So this guy right here is pronounced f of x. Okay, so I want to know what the function is. Okay, this is the function or equation of this value of x. Okay, so this is how they're going to write an equation in function notation. Okay, so as we look through here, we have, you see this equation here with, y equals 3x plus 2. Okay, y is the output, x is the input. That has not changed. Same thing, domain, range, all those are all the same thing. Okay, so now instead of y equals 3x plus 2, we have f of x equals 3x plus 2. This is still the output, x is still the input. And you'll notice they go one step further, and this time they say f of 1 is equal to 3 times 1 plus 2. You'll notice that instead of an x, they have a 1 in place of those. Well, what this means here, this number inside this parentheses, means that you're going to substitute 1 in for the equation for x. And then you're going to simplify. So all this is just a fancy way to simply substitute. That's all it is a fancy way to substitute. Okay? All right, so now let's take a look at some of these examples. It says, for f of x equals negative 2x plus 5, what's the output for the inputs? Negative 3, 0, and 1/4. So what they're asking for is, they're asking you to find f of negative 3, they're asking you to find f of 0, and they're asking you to find f of 1/4. Okay, so now as I go through these examples, all we're going to do is we are going to substitute those values into this equation. So it's going to be negative 2, and instead of x, it's going to be times negative 3, and then plus 5. And you're going to use PEMDAS from here. So I'm looking for parentheses. There's no, in this case, we do have some parentheses, but it is multiplication. There's no exponents or anything. So we're going to do multiplication. So I got negative 2 times negative 3, and that's positive 6. And then we have no more multiplication division, so now we're going to do addition subtraction. And that's going to be 11. So f of negative 3, or when I put negative 3 into the equation, I'm going to get 11 out. This is my input, that's my output. When I put 0 in, I get negative 2 times 0, and then plus 5. Negative 2 times 0 is 0, plus 5 is 5, so f of 0 is 5. So again, when I put the 0 in, I get a 5 out. And then the last one, 1/4, when I put 1/4 in, negative 2 times 1/4 plus 5. And we're going to use our calculator here. So negative 2 times 1/4 is going to give me negative 0.5. And then we're going to add 5 to that. So if I take negative 0.5 and I add 5 to it, that is 4.5. So when I put 1/4 in, I get I get 4.5 out. Okay, so let's take a look at these other few examples here. This time I want to know f of negative 2. Going to plug in negative 2. Negative 4 times negative 2, doing PEMDAS here. So I've got multiplication here first, so this is positive 8. And when I add 1, f of negative 2 equals 9. Or if I wanted to write these guys as ordered pairs, my x value that I put in is negative 2. My y value that I got out is 9. Negative 2 and 9 is my input and output, or my domain range, however you want to say that. Okay, let's go through the last one here, and then I'm going to skip this B so that you can get to work on your examples. F of 5. So negative 4 times 5, and then plus 1. Negative 4 times 5 is negative 20. Plus 1 tells me that f of 5 is negative 19. Now, one of the things that I think is a common mistake with these is that you think this is multiplication, so now I have to divide by 5. That's not true. This is just a notation. Okay, this is not f times 5. This is f of 5. It's completely different. This is telling me what I'm putting in. That's telling me what I'm getting out. Okay, now you should be able to complete the examples here on the first page.